In 2019, the Proxima Telescope in Australia had been closely monitoring Alpha Centauri, more specifically Proxima Centauri, our nearest star system. The main objective was to determine whether Proxima Centauri's habitable zone exoplanet, Proxima B, could support life. However, during this research, a strange radio signal was detected by Shane Smith, an undergraduate student involved with SETI. The peculiarity of this signal was immediately apparent when Smith shared his findings with senior researchers. Unlike any natural cosmic signal previously observed, this radio wave bore an artificial structure, resembling signals typically generated by human-made satellites and spacecraft. The signal was detected in the narrowband range of 982 MHz, a frequency band usually exclusive to artificial technology. To rule out the possibility that this was simply an Earth-originated signal bouncing back, astronomers conducted thorough studies. The conclusion was striking. The signal was not of terrestrial origin. Instead, it appeared to be coming from deep interstellar space, fluctuating in a periodic manner, suggesting it originated from a source undergoing systematic motion. This discovery generated significant excitement within the scientific community. The signal was named Breakthrough Listen Candidate -1, or BLC-1. What added to the intrigue was that this radio transmission seemed to emanate from the general direction of Proxima Centauri, specifically from the region where Proxima B orbits its parent star. Though its exact origin could not be pinpointed, scientists had reason to speculate that it might have originated from Proxima B itself. This planet, being the closest Earth-like exoplanet to us and situated in Proxima Centauri's habitable zone, was already a prime candidate for hosting life. To verify this theory, Smith and his mentors decided to reposition the telescope away from Proxima Centauri and check whether the signal persisted. As soon as they did this, the signal disappeared. This was an astonishing discovery. It confirmed that the signal was indeed coming from Proxima Centauri's direction. However, despite this strong correlation, there remained considerable uncertainty. Given that a portion of the Alpha Centauri system remains obscured from Earth's northern hemisphere due to the curvature of our planet, some parts of the system remain unseen to many astronomers. Therefore, the true source of the signal could still be hidden beyond our observational reach. To better understand this, we need to analyze the Alpha Centauri system. It consists of a binary star pair, Alpha Centauri A and B, both similar to our Sun. Orbiting these two is Proxima Centauri, a red dwarf star much smaller and dimmer than its stellar companions. Importantly, Proxima Centauri is the only one in this system known to have exoplanets, with Proxima B being the most promising due to its position within the habitable zone. However, there's a significant challenge to Proxima B's potential habitability. Proxima Centauri, like many red dwarf stars, is extremely volatile, emitting intense X-ray and ultraviolet radiation. Compared to Earth, Proxima B receives approximately 500 times more X-ray radiation annually, making its surface conditions highly unpredictable. A notable example of this occurred in March 2017, when Proxima Centauri suddenly flared up, becoming 1,000 times brighter within just 10 seconds. If such an event were to occur on Earth's Sun, it would cause catastrophic consequences, possibly rendering the planet uninhabitable. While this makes Proxima B's habitability questionable, the signal detection still posed an unanswered mystery. Notably, researchers observed that the signal was present for about 30 hours before vanishing. This is unusual because artificial signals from satellites typically move quickly across the sky due to their orbital motion. This discrepancy left scientists puzzled about whether the signal was genuinely from an extraterrestrial intelligence or merely a bizarre cosmic phenomenon. Renowned planetary scientist Francis Marchese, a senior researcher at the SETI Institute, expressed skepticism. He pointed out that if there were intelligent extraterrestrial civilizations using radio technology similar to ours, it would be an extraordinary coincidence for them to be in such close proximity within our galaxy. With over 300 million potentially habitable exoplanets in the Milky Way, the likelihood that two neighboring star systems, Earth and Proxima Centauri, evolved nearly identical radio communication technologies seems almost impossibly low. To illustrate this improbability, one could compare it to rolling 100 dice and expecting 16 of them to land on the same number, not just anywhere, but in the same clustered position, a scenario highly unlikely to happen by chance. Given these uncertainties, some researchers propose an alternative method of searching for life on Proxima B. Instead of looking for radio signals, They suggest focusing on detecting artificial lights on the planet's surface. Since Proxima B is likely tidally locked, meaning one side always faces its star while the other remains in perpetual darkness, an advanced civilization might inhabit its dark side, using artificial lighting to survive. The upcoming James Webb Space Telescope and future observatories like the LUVOIR Space Observatory could potentially detect such light emissions. However, skepticism remains. Scientists argue that if life evolved in Proxima B's dark region, it would likely adapt to its environment rather than rely on artificial lighting. Earth's deep-sea creatures, for example, produce their own bioluminescence instead of using external light sources. If extraterrestrial life forms exist in Proxima B's oceans, they might use a similar strategy, rendering artificial light searches ineffective. To gain definitive answers, a more direct approach is necessary. This is where the Breakthrough Starshot project comes into play. Scientists are working on deploying ultralight spacecraft, propelled by powerful laser beams, to travel at 20% the speed of light toward Proxima Centauri. If successful, these probes could reach Proxima B within a few decades and send back high-resolution data on its atmosphere, magnetic field, and potential biosignatures. Until such a mission is realized, the mystery of BLC-1 remains. It is reminiscent of the famous 1977 WOW signal, another unexplained radio transmission that has never been detected again. The only concrete fact about BLC-1 is that it originated from a region approximately 1,800 light-years away in the Sagittarius constellation, near the Sun-like star 2 MASS 192819822640123. Beyond that, its origins remain speculative. So, is the search for extraterrestrial intelligence still ongoing? Absolutely. The continued study of both the WOW signal and the Proxima Centauri radio signals represents our enduring curiosity about the universe. While we cannot yet confirm that aliens are trying to communicate with us, the possibility that intelligent life could exist elsewhere remains tantalizing. But what if aliens don't look like what we imagine? While we often envision them as gray-skinned beings with large heads and big eyes, what if they look just like us? If that were the case, how would we ever distinguish between humans and extraterrestrials? With that thought-provoking question, what do you think? Are the mysterious signals from Proxima Centauri evidence of alien intelligence, or could there be another explanation? Share your thoughts in the comments below. And if you found this information fascinating, don't forget to like and subscribe for more mind-expanding content. Until next time, stay curious.